Till now in function, I already discussed one-to-one function, onto function and bijection. Today I will discuss inverse function. If f of a equals to b, we can say f inverse b equals to a. So f is a function from set A to set B. F inverse is a function from set B to set A. It's inverse of function. Now definition of inverse function, let f be a one-to-one correspondence from set A to set B. If a function is not one-to-one correspondence, we cannot find its inverse. One-to-one correspondence means it's a bijection. It's both one-to-one and onto. Then only we can find its inverse. The inverse function of f is the function that assigned to one element b belongs to set B, the unique element a in set A such that f of a equals to b. If f of a equals to b, f inverse b equals to a. We can write inverse this way, f above that inverse. And don't confuse between f inverse and 1 by f. Both are different. This is inverse, this is 1 divide function. If a function is not one-to-one correspondence, we cannot find inverse of it. If a function is not one-to-one, then when we will find inverse, there may be multiple image for it. Like let A, B, C, 1, 2, 3. 1 maps to 2, B maps to 1, C maps to 2. This is not one to one, right? Now when we'll find F inverse 2, it can't be A and C. If one mapping contains two elements, then it is not a function. Here F inverse 2 equals to A and C, so this is not a function. So that's why for inverse it should be one-to-one and onto. Now this example is also not onto as 3 is free. When we will find F inverse 3 will be nothing as no domain maps to 3. So we cannot find F inverse 3. That's why it should be both one-to-one and onto. If a function is not one-to-one, some element b in the codomain is the image of more than one element in the domain. And if it is not onto, then for some element b in the codomain, no element a in the domain exists for which f of a equals to b. There may be some free element in set B for which we cannot find its inverse. So one function is invertible if it is one-to-one correspondence, and it is not invertible if it is not one-to-one correspondence. Now diagram for inverse, if f is a function from set A to B, then f inverse is a function from set B to A. We can say f of A equals to B, then f inverse B equals to A. So f of A equals to B and f inverse B equals to A. It's just opposite of function. Let's see one example. Example 15. Let f be a function from a, b, c to 1, 2, 3. One set contain a, b, c. Another set contain 1, 2, 3. Now f of a equals to 2, f of b equals to 3 and f of c equals to 1. Is f invertible, and if it is, what is its inverse? Yes, f is invertible as the function is both one-to-one and onto. One-to-one as for A, B, C, different codomains are present. F of A is 2, F of B is 3, F of C is 1. All are different, so it is one-to-one. Also it is onto as 1, 2, 3, all are images. As it is both one-to-one and onto, you can say it is one-to-one correspondence, hence it is invertible. We can find inverse of it. Now F inverse 1 will be C, and F inverse 2 is A, and F inverse 3 is B. Next example 16, let f z implies z be such that f of x equals to x plus 1. Is f invertible, and if it is, what is its inverse? Yes, it is invertible as it is one-to-one correspondence. It is both one-to-one and onto, hence it is invertible. I already discussed same example in 1 to 1 and on to, and I proved that this is both 1 to 1 and on to. Let x plus 1 equals to y. So f of x equals to y. We can say f inverse y equals to x, or we can write in term of y as x plus 1 equals to y. We can write x equals to y minus 1. We can take this 1 to right side. So here in place of x we can write y minus 1. So f inverse y equals to y minus 1. Next example 17, let f be a function from R to R with f of x equals to x square. Is f invertible? I already discussed same example, it's not 1 to 1. As f of 1 equals to 1, f of minus 1 is also 1. And f of 2 equals to 4, 2 square, f of minus 2 is also 4. So as 1 minus 1 both maps to 1, 2 minus 2 both maps to 4, 3 minus 3 both maps to 9. So this is not a one-to-one function. As this is not one-to-one function, so it is not invertible. Not one-to-one means not one-to-one correspondence, hence it is not invertible. We cannot find inverse of it. In today's lecture, I discussed inverse function. In next lecture, I will discuss composition of function. If today's lecture is helpful for you, please like, share and subscribe. Thank you. Bye-bye.